So hello everyone, let us solve today's GfG problem of the day, and the problem name is maximum sum path in two arrays. So let us read the problem statement. So given two sorted arrays of distinct integers ARR1 and ARR2. Each array may have some elements in common with the other array. We need to find the maximum sum of a path from beginning of any array to the end of any array. And you can switch from one array to another array only at the common elements. So if there are common elements, let's say in ARR1 and ARR2, so we can just switch from ARR1 to ARR2 or ARR2 to ARR1. Yes, so they have given the additional note which says the same. When we switch from one array to another, we need to consider the common element only once in the result. So this is obviously, so if we are meeting at some common element, so we don't count that common element twice, we will count only once in our sum. So this is the question. So let us see this first example and try to understand this question in more better way and find some solution out of it. So this is the first example that they have given, and this is ARR1 and this is ARR2. So this question is slight variation of merge sort. So merge sort is prerequisite for this question. So this is slight variation of it, and the most special thing about these two arrays is that they are in sorted order. So we can apply this merge sort technique in this question. So this is slight variation of merge sort. So let's see how we can apply merge sort in this question. So what all possibilities I can have for our maximum sum path? So one possibility is that I can have maximum sum as this entire array, or I can have maximum sum as this entire array ARR2. So these are two possibilities. The other two possibilities can be I have maximum sum from ARR1 till this element, and then I switch to ARR2 because these two elements are common. So I switch from ARR1 to ARR2. So this is another possibility for our maximum sum. Another possibility can be I take ARR2 sum till here and then I switch to here, because 7 is the common element, so I can switch from ARR2 to ARR1. So these are the four possible cases which we need to cover, and we will see how we can use this merge sort technique to get our final answer. So let us dry run on this example test case and let us see how our algorithm will work. So what I need to do now, let me maintain two variables I and j. So I will iterate through the ARR1, j will iterate through the ARR2. Also I will maintain two sum variables, sum a and sum b. Sum a will maintain the sum of ARR1, sum b will maintain the sum of ARR2. Now what we need to do now, whenever we find any common element, what we will do, we will take the maximum of this sum a and sum b. We'll take the maximum and store it in our answer. So we will also maintain one answer variable which will be like giving us the maximum sum path. So this will be the final answer that we will return. So whenever we find any common element, we will take maximum of sum a and sum b and add it to our answer. So this is what we need to do, and after that we will again reset our sum a to 0 as well as sum b to 0, because we can have four possibilities. So initializing again it with 0 will cover all four cases, because what can happen, either we will go to the same array for the iteration, or we can switch to some different array. So initializing again with 0 will cover all the cases. So let us see how this algorithm will work. So sum a and sum b, let me again initialize that. So initially sum a will be 0 and sum b will be 0. So what we need to do now, we need to iterate on both the arrays until we find any common element. So we will check what is the smaller element amongst ARR1 and ARR2. We will add it to their corresponding sum and we will iterate. So let me show you. So initially ARR1 of I is 2, ARR2 of j is 1. So moving j pointer ahead will have more possibility that we can find any common element rather than moving this I pointer, because this is already greater than 1. So it's better to move our j pointer ahead. So if we are moving our j pointer ahead, we need to store this 1 into our sum b. So we store sum b equal to 1. Now we'll move ahead with our j pointer, and our I pointer will remain same. Now amongst 2 and 5, which is lesser? Obviously this 2 is lesser, so we will store 2 in our sum a and we will move ahead with our I pointer. Amongst 3 and 5, which is lesser? Again from ARR1 this 3 is lesser, so we will store it in our sum a and we will move ahead. Now what will happen? We have 7 and we have 5. So 5 is lesser than 7, so we will move ahead with 5 and we will point to 7, as well as we will store sum in sum b. So sum a till now is 5 and sum b till now is 6. So let me write this. Sum a till now is 5 and it is 6. So let me just erase this. So yeah, this is the scenario till now. Now we find one common element. So now we need to find what is the maximum sum till now that we have. So we found this common element at 7. So amongst sum a and sum b, which is the maximum sum till now? Obviously this sum b. So we will store, so we will also declare one answer variable. Obviously I didn't declare it here. So we will store this sum b sum in our answer, because this is the maximum sum that we have till now and we need to take care of the maximum sum path. So we'll store this 6 in our answer, as well as we need to also consider this common element, because obviously we will consider the common element also in our sum only once. So we can do anything, either ARR of I or ARR2 of j, ARR1 of I or ARR2 of j. So anything we can do. So our answer till now will be 6 plus 7, that is 13. And again we will reset our sum a to 0 and sum b to 0. So sum a is 0, sum b is 0. Now we have taken care of this common element, so we will move forward with our I pointer as well as our j pointer. Now again we need to do the same thing. Amongst 10 and 8, which is the smaller element? Obviously 8 is the smaller element, so we will add 8 to our sum b. Now if when we move ahead with our j pointer, we will reach the end of ARR2. So now we need to consider only ARR1 elements. So we now have nothing to compare ARR1 elements. So we can just keep on adding this sum to our sum a, ARR1 elements to our sum a. So in the end sum a will be 22 and sum b will be 8. Now in the end again we need to add what is the maximum of both of these. So maximum of 22 and 8 is 22. So we'll add 20 to our final answer. So what is the final answer that we are getting? 13 plus 22 is 35. So this should be the maximum sum path that we should get. And if you see it carefully, this is the correct answer that we are getting. So this is how this algorithm will work. So this is slight variation of merge sort. So merge sort is the prerequisite for this question. So let us directly write the code now and understand in more better way. So let us write the code now. So initially I'll declare the n as the size of ARR1, m as the size of ARR2. Also I need to declare two variables I and j. Initially they will be 0, pointing to the beginning of corresponding arrays. Now what we need to do, we will run a while loop until any one of the pointer gets to end of the corresponding array. So j is less than m. What we have seen, we can have three possibilities. Either element of ARR1 is lesser than ARR of 2, or we can have ARR2's element lesser than ARR1's array. And what was the third scenario? Third scenario was that both elements are equal. So we will see these three scenarios now. So if ARR1 of I is less than ARR2 of j, so what we have seen, we need to consider the smaller element. So I need to declare the sum variables also. Sum a will be initially 0, sum b will be initially to 0. So if ARR1 element is lesser than ARR2 element, so we will update our sum a variable. So sum a plus equal to ARR1 of I, because we need to consider the smaller element, and then I plus plus. Else if what is the scenario, it can have that ARR2 element is lesser than ARR1 element. So ARR2 of j is lesser than ARR1 of I. So what we will do, we will update our sum b. Sum b will be what? ARR2 of j will be added, and j plus plus as usually. Otherwise what we can have? We can have at the common element. So we are now pointing at the common element. So at common element, what we will do? We'll update our answer with the maximum sum. So I need to also declare one answer variable which will be initially 0. So we will update our answer variable to what? Whatever is the maximum sum till now. So what is the maximum sum till now among sum A and sum B? As well as we need to also add that common element. So we will add that common element. So you can write ARR1 of I or ARR2 of j. And now we have considered that common element also. So we need to again reset our sum variables. So we'll sum A equal to 0, sum B equal to 0, and then just move ahead in our array. So this will keep on happening until any one of the array is passed, or any one of the pointer is reached to the end of the array. Now if it is reached to the end of the array, there are two possibilities. Either array 1 is finished or array 2 is finished. So if array 2 is finished, we need to take only array 1 elements. So we will write like this. So until our array 1 is also not finished, we'll keep on adding it to our sum A variable. So sum A plus equal to ARR1 of I plus plus. What can be the other possibility? Other possibility can be that ARR1 was finished earlier. So we need to take care of the only ARR2 elements. So we will again iterate through the ARR2 array until this is also finished. So now we don't have to compare any elements, because these elements are alone. We need to we can't compare it with array 1 elements, because array 1 elements array 1 was already passed by the I pointer. So sum b plus equal to ARR2 of j, and then j plus plus. In the end, what can happen? As we have seen, we need to again consider the maximum sum till now. What we have? Sum A comma sum B. So this is what the code looks like, and we will return this final answer as ANS. So let me correct that. Yes. So what we are doing? We are iterating to both the arrays. We are looking for one common element. So until we find any common element, we will just update our I pointer and j pointer, whichever is the lesser. If array 1's element is lesser than array 2's element, we will update our sum A. Otherwise, we will update our sum B. If we find any common element, what we will do? We will just take the maximum sum that we have till now and the common element. We will again reset our sum A and sum B to 0. If any one of the array is finished, we will take care of its other array. Like if array 1 is finished, we will take care of the array 2. If array 2 is finished, we will take care of only array 1 elements. So we are again iterating to the remaining elements of either of the array. In the end, again, whatever is the maximum sum that we have till now, we will add it to our final answer. And in the end, we will just return that final answer. So this is how this code will work. So let us see if this gets accepted or not. So yeah, our code got accepted successfully. Hope you learned from this video. Thank you.